Hello there, this is a geometry video. It is chapter 7, section 7, and this is the last section of the chapter. So you know what that means, dun dun dun, test time. So make sure that you are getting yourself prepared for that. So today we're going to be talking about scale drawings and models, and we're going to be using proportions to do this. I will say that for this first example, there's a map. And I could not draw the map of Tennessee, even if I wanted to. It's quite strange. But basically, you need to go to page 518 in your textbook, and then you'll know what I'm talking about. You're going to need a ruler. To be able to do the example, at least to the full. It's actually a pretty short lesson. It's pretty straightforward, but just so you know, I'm not drawing the map up here. But the scale on the map that is in your book is 0.4 inches to 40 miles. That means that every 0.4 inches on the map represent 40 miles in actual life, if you will. So they want us to find the actual distance from Nashville to Memphis. In order for you to do that, you actually have to take your ruler and measure the distance between Nashville and Memphis on your map. So since I don't actually have the map up on the board right now, I'm going to tell you that we have previously measured this with a ruler, and the distance between Nashville and Memphis is basically 1.5 inches. So this has been already measured, and it's 1.5 inches. So all you want to do is basically set up a proportion. You know that 0.4 inches is basically, the way I like to think of it, is model versus actual. It doesn't really matter whether you put model on top or actual on top, as long as you stay consistent. In this case, I'm going to go from model to actual. So in the model, you have 0.4 inches, but in actuality, it's 40 miles, according to the information given. And then you equate that to the ratio of what we measured on the map, which is 1.5 inches. So this is the model, represents 1.5 inches, and then what we're looking for is the actual distance. We don't know what that is, so we're going to call that x, and that's basically all you have to do. We're going to set this up, and now we're just going to solve. So we're going to get 0.4x is equal to 1.5 times 40, and we're going to use a trusty little calculadora to make sure that we get that correct. It's not really that hard to do. It's probably going to be 60, but let's just confirm that. What do you know? So 0.4x equals 60, divide by 0.4 on both sides. And lo and behold, the actual distance from Nashville to Memphis is 150 miles. And that is how you do scale drawings and models. So there's a do-it-yourself question here. It says find the actual distance between Nashville and Chattanooga. Again, you're going to need a ruler, and you take your little map and you'll measure the distance between Nashville and Chattanooga, and then go from there as far as setting a proportion. So here's another example. Again, it seems kind of weird because it says this is a miniature replica of a 1923 checker cab, and it's like not even there. That's because it's on page 519 in your textbook, as it says so up there. So according to the information we have, it says the length of the model is 6.5 inches. So again, we have the model length, but the actual length is 13 feet. So it says here, what is the scale of the model? You have 6.5 inches to 13 feet. So I'm pretty sure that you can reduce that because 6.5 goes into 13 twice. So you basically have 1 inch to 2 feet, or you can write 1 inch to 2 feet, whichever you prefer there. So for part A, that's all you have to do is 1 inch to 2 feet. That's your scale model right there. And then part B says how many times as long as the actual card is the model. So in order to do that, you're going to want to set up your little thing here. So we're going to first convert what we already have. So we already know that we have 1 inch to 2 feet, but you might be wondering, you've got two different units there. You've got inches and you've got feet. So in order for us to be able to answer this question, we have to convert our feet to inches or our inches to feet, but it'd be a lot easier to convert our feet to inches. So we know that there's 12 inches in each foot. So we're going to go 1 foot to 12 inches. We're converting here. So remember we talked about that. You want to make sure that the feet cancel. So you want to put the 1 foot on top and the 12 inches on the bottom here, so that these feet will cancel there. And then your inches. So we're going to end up with 1 over 2 times 12 is 24. So the question was, how many times as long as the actual car is a model? It's 1/24 as long. That is your answer right there, 1/24 as long as the actual, so it's quite smaller. All right, so now you're going to try the same thing with this do-it-yourself question. And then we're going to go to our last example, very short lesson today. And it says, suppose you want to build a model of the St. I don't know if that's St. Louis or St. Louis Gateway Arc. It's a good thing I'm not an English teacher. But anywho, you want to build this model of this wonderful place here that is no more than 11 inches tall. So you don't want your model to be any larger than 11 inches. It says choose an appropriate scale and use it to determine the height of the model. And then of course use the information on page 519. So there is a little blip about this arc in your textbook at the bottom of the page. And it says here that the St. Louis Gateway Arc is the tallest national monument in the United States. And it's at 630 feet. So the actual length is height is 630 feet. And it gives us some more information about its its actual span. It talks about how much it weighs. But for the purpose of what we're doing here, we just need to know how tall it is. So it's 630 feet tall. But you want your model to be no more than 11 inches tall. So what we're going to do is we're going to take 630 and we are going to divide it by 11, because that's or you don't want it to be any taller than that. So 630 divided by 11 is actually 57.3, approximately 57.272727, repeating. It's approximately 57.3. So it says here, choose an appropriate scale. You don't want to use 57.3, that's just a very strange number. So since 57.3 is close to 60, it would make sense for us to use a scale that is 60. So 1 inch, we're going to say that our appropriate scale is going to be 1 inch, is going to be equal to approximately 60 feet. So that's the first part, is to choose an appropriate scale. And then it wants, let's see what else it would say here. And then they want to determine the height on the model. So again, we're going to say the model is 1 inch and the actual is 60 feet. So we're going to go to a model to actual is how I'm setting up my proportion. So over here, in the case of the model, we know that it's going to be X units. So they want us to find the actual height of the model. So we don't know what that is right now. We're going to call it X. Hopefully it's less than 11. And on the bottom, we're going to put the actual height of the arc, which is 630. And so just like that, you're going to solve this little sucker. So 60 times X is going to be 60X. And 1 times 630 is 630. Divide by 60. And we're going to get our answer here. I don't know why I put my calculator away, but I did. So 630 divided by 60 is going to give you 10.5. Which, lucky for us, is no more than 11 inches tall. It's 10.5 inches tall. Alrighty, so that is how you do this example. So we're going to let you, see if I can turn that page, do it-yourself number 3. And once you have finished this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.